Hello and welcome to School of Next Gen. Today, the scary lookalike equations we have to solve, right? So the ultimate goal is to find the value of x and y, and of course there are some condition. The condition is x and y belongs to the integer number. And this scary lookalike equation have solved by the greatest Indian mathematician Srinivasa Ramanujan, who contributes to the analytical theory of numbers and worked for continued fractions, elliptic functions, and finite series. And he is the fellow of Royal Society. And this solution I'm going to tribute to Mr. Srinivasa Ramanujan. Let's start. This is equation number 1 and this is equation number 2. And consider square root of x is equals to p and square root of y is equals to q. If we squaring both sides, so we could find square root of x mean x, and this will be p square, same as this will be y, and of course this will be q square. Now if we plug in the value of square root of x and y in equation number 2, we'll find this will be p plus q square is equals to 7. Same as from the equation number 1, we'll find the value of x mean p square and plus square root of y mean q is equals to 11. Now rearrange this equation. It means 7 we could split it into 7 plus 4. Why 7? Because we know the value of 7 is equals to this one. Now plug in the value of 7 instead, p plus q square plus 4, and of course the left hand side will be same as p square plus q. Now if we could rearrange this value, so we could write down p square minus q square plus q minus p is equals to 4. And here this portion and this portion, what I am seeing, can you see that? Yes, this is actually a difference of equation formula, right? So difference of square formula means a square minus b square. So we could write down instead of a, this should be p plus q, but then this is p actually and q, then p minus q, and of course we have to rearrange these things. So indeed we could write down here p minus q equals to 4. It means we could go back to the previous q minus p. From here to here it is possible, so we just rearrange here, right? Anyways, here if we could take common p minus q and p minus q, so it will be p minus q, and here will be p plus q minus 1 is equals to 4, right? Now we could have 3 options instead of 4. We could write down 4 times 1, which is 4, or 1 times 4 is 4 as well. 2 times 2 is equals to 4. It means either 4 times 1 is equals to this part, or 1 multiply 4 will be equal to this part, or 2 times 2 is equals to this part. So we have actually 3 1. So consider this is case number 1. For case number 1, p minus q times p plus q minus 1 is equals to 4 times 1. Indeed, we could write down P minus Q is equals to 4 and P plus Q minus 1 is equals to 1. Now solve P and Q, I mean this equation and this equation. We have to find the value of P and Q. Let's try now. So here P minus Q is equals to 4. From here we could write down P plus Q is equals to 2. We put it here. So P plus Q is equals to 2. So positive negative cancel out. Here 2P is equals to 6. So P equals to 3. From here we could write down the value of Q is equals to 2 minus P, right? So this is 2 minus 3. So the value of Q is equals to minus 1. So here P is positive integer, but the Q is negative integer. But the condition said in the question that X and Y belongs to positive integer. So for this case, it is not possible to find the value of X and Y. So we have to move for the case number 2. Case number 2. Case number 2. So here P minus Q, P plus Q minus 1 is equals to what was, now we have to write here 1 times 4, right? It means P minus Q is equals to 1 and here P plus Q minus 1 equals to 4. So from here P plus Q is equals to 5. Now put it here, P plus Q is equals to 5. So this is plus, this is minus, cancel out each other. So here 2P is equals to 6. So here again P is equals to 3. Now time to check the value of Q is equals to 5 minus 3. So it will be 2. So P comma Q is equals to 3, 2. So both are positive integer. So we have to find the value of X and Y. Instead P and Q, of course. So this is actually positive integer. So this is possible to find out the value. So write down possible to find out the value. Now case number 3. So case number 3. Case number 3. P minus Q, P plus Q minus 1 is equals to 2 times 2. So here P minus Q is equals to 2. P plus Q minus 1 is equals to 2 as well. So P plus Q is equals to 3. So plug in here or put it here, plus Q is equals to 3, right? So plus minus cancel out. 2P is equals to 5. So P is equals to 5 by 2, which is fraction actually. So this is not possible. Of course Q also, after calculation we could find the value of half. So this is a fraction number, this is a fraction number as well. So it is not possible because this is a fraction number, right? Now we already have got the value of P and Q, which is integer, we got from case number 2. So case number 1 and case number 3 we could not find the value, but case number 2 we already have got the value of P and the Q, which is 3 and 2. So here the value of P is 3 and of course 2. So if we replace the value of P and replace the value of Q here, so X is equals to P square, right? And the value of P is 3 square. So the value will be 9 here, X equals to, and here Y is equals to Q square. So let's plug in the value of Q is 2 square. So here we'll be getting the value of Y is 4. So the final answer will be X, Y is equals to 9, 4. So this is the final result. Of course, the argument said X and Y is belongs to the positive integer, and of course 9 and 4 is the positive answer. Thank you so much.